On the 4th of October, 1957, the Union of Soviet Socialist Republics, better known as the Soviet Union, launched the Sputnik rocket from Baikonur Cosmodrome Site 15 in Kazakhstan, carrying a payload that would forever change human history. Its launch would precipitate the period of public fear and anxiety in the United States about the potential technology the Soviets had at their fingertips, a time known as the Sputnik Crisis. Previously, the USA believed they had a technological advantage when it came to things like the U-2 spy plane and its demonstration of superior nuclear capabilities. However, now the Soviets had proven that they could put a man-made object into space indefinitely, providing an unimaginable military reconnaissance advantage and creating a serious perceived threat to national security. All of this political tension would eventually kick off the space race, being an extended period of space technology and technique development between the two nations, ultimately culminating in the success of the Apollo program, which put the first and, to date, only boots on the moon, and the failure of the competing Soviet N-1 program. The space race would, more or less, go down in history as an American victory. Nowadays, that perception is being questioned, and there are misconceptions that I'd like to make an effort to clear up. I will do my best to be as unbiased as possible, but today, I want to expose the USSR's perceived space superiority for what it truly was. And what was it? In my opinion, it was a tenuous grasp on a series of complicated parlor tricks that, while undeniably impressive, were often rushed, dangerous, and underdeveloped in a politically motivated and desperate attempt to maintain a perceived place of leadership over the USA. Part of the reason I'm making this video is because of tankies. What are tankies, you may ask? Well, essentially, a tankie is a person who supports far-left authoritarian regimes, such as modern-day Stalinists. The name is derived from the British Communist Party's defense of the Soviet Union's use of tanks to quell the 1956 Hungarian Revolution. These days, tankies mostly exist as internet LARPers, having soaked up pro-communist propaganda in order to spit it back out onto social media, many not realizing the reality of what it's like to actually live under these regimes. Recently, I came across a group of tankies on Twitter who are perpetuating an old meme format that states essentially that the actual victors of the space race were the Soviets, as they made every possible achievement except a crude lunar landing. Now, there is a number of things wrong with this meme, the first being that it intentionally omits any and all achievements made by the United States, such as the first rendezvous and docking, first visit to an outer planet, and first to achieve escape velocity, to name a few. Personally, I like to use this version of the meme, as it more accurately portrays the reality of the space race achievements. There's also this one, which is just kind of funny. Thanks, Talv. Setting aside the lies through omission, tankies also like to make the claim that there is actually no space race at all, that this is an American myth perpetuated to reinforce their own victory. They claim that the Soviets weren't racing, but making these achievements in the name of scientific progress and all of humanity without involving politics. This is demonstrably false, and while you'll see more evidence of this throughout the video, we can first look at the way the Soviet space program was promoted. Let's see some old propaganda posters, shall we? This one says, "Glory to the Soviet people, the pioneers of space." That's one of the more subtle ones. This one says, with Lenin's name. This one says, "Socialism is our launching pad." Lastly, this one says, "Sons of October, pioneers of the universe." Sons of October referring to the October Revolution, also known as the Bolshevik Revolution. The truth is that the Soviet space program was inherently political, just like the United States one. And for this reason, the program suffered immensely from being rushed, underdeveloped, undertested, and dangerous. Many held no purpose other than to be the first to do it, and when the USA inevitably caught up, sometimes very quickly, they had often managed to take their time to fully develop and flesh out their missions. One could even argue that the US achievements hold more weight because what the Soviets did to be first, the USA did to actually make progress. One could make that argument. I'm not quite doing that though. I want you to take another look at this list. Over the course of this video, we're going to break down and examine the details of every single one of these achievements, discuss what actually happened, and put these historic events into the proper context. The title of this video uses quotation marks for a very obvious reason. It is no myth that the Soviets once held all leadership in space, but the tale of that leadership has been, at least somewhat, exaggerated. While most of the achievements on this pro-Soviet meme are things that actually happened, one particular event is simply not true. First to space. It's sometimes also reworded as first space rocket. Who was the first to put a man-made object above the Kármán line, usually recognized as 100 kilometers or 62 miles in altitude? Well, unfortunately, it was not the Soviet Union. It wasn't the United States either. That achievement belongs, believe it or not, to Nazi Germany. Yeah. Aerospace fans in general try to just forget about this. Most people who are familiar with any amount of space history are aware that the first rockets to be used as space experiments were modified V-2 rockets that the US Army had captured from the Wehrmacht, the armed forces of Nazi Germany. The Soviets also managed to capture a number of V-2 rockets, and both nations would go on to use them to design their own launch vehicles. However, all of this would take place after June 20th, 1944. On that day, at the Peenemünde Army Research Center in Germany, the Wehrmacht launched a V-2 rocket that traveled to an altitude of 176 kilometers or 109 miles, which is well above the Kármán line. Earlier attempts had failed from serious reliability issues, and improvement efforts were massively hindered by the ongoing war and continued Allied advances. However, MW-18014, as it was designated, became the first man-made object to intentionally enter space. It's just that the Nazis weren't trying to enter space. All they were doing was testing the limits of what the V-2 was capable of. How high could a pure vertical launch get, how best they could maximize its potential range, and in doing so, they sent a rocket past an invisible line that they didn't know was there, and that wouldn't actually be named until the 1960s. Now, with that being said, the next nation to send a rocket to space was still not the Soviet Union. Unless I am later corrected, and you'll see it in a pinned comment, the next rocket to enter space was V-2 sounding rocket number 3, launched by the US Army on the 10th of May, 1946. This was part of all that captured V-2 testing that I mentioned, and would include such usually unmentioned achievements such as the first animals in space. So, this one aspect of the pro-Soviet meme is outright wrong, and now that we've addressed that, we can move on to the actual achievements of these heavily competing nations. When Sputnik 1 was launched in 1957, it did indeed become the world's first artificial satellite, by all reasonable definitions. This aspect of it cannot be disputed. The mathematics for orbital rocket launches had been theorized and worked out as early as 1903, when Konstantin Tsiolkovsky published his work The Exploration of Cosmic Space by Means of Reaction Devices, which is considered the first realistic proposal for spaceflight. While this theoretical work wasn't widely influential outside of Russia, Robert H. Goddard's 1919 publication, A Method of Reaching Extreme Altitudes, lent a lot of credence to the idea that liquid-fueled rockets could achieve interplanetary travel. This latter proposal would heavily influence German scientist Wernher von Braun and his development of the V-2 rocket during World War II. However, with all of this groundwork already having been laid, to develop and implement the technology to actually propel a working spacecraft into a relatively stable orbit around the Earth is an undeniably impressive feat. The basis for the Sputnik rocket, and really the vast majority of Soviet launch vehicles, was the R-7 Semyorka, the world's first intercontinental ballistic missile. The principle of Soviet rocketry existed in extreme contrast to that of the United States. The US Army and later NASA preferred to contract out rocket designs to various manufacturers and custom build each launch vehicle for specific purposes, though for a period of time, the US would also rely heavily on an ICBM-derived vehicle, the Titan family. The Soviet Union, however, found that they had a robust and reliable design in the form of the R-7 and would, for the most part, continue to build on this basic rocket, improving it and expanding its capabilities. In many ways, Soviet rockets exemplify the unofficial Russian motto of "if it ain't broke, don't fix it." For this reason, I won't talk much about the specifics of the Soviet launch vehicles themselves, as the vast majority of them are, on the surface, the same. Sputnik 1 was launched into an elliptical orbit of 215 kilometers or 134 miles by 939 kilometers or 583 miles. It operated for 21 days in orbit, providing valuable information regarding the density of the upper atmosphere by analysis of its drag on the orbit, and the radio waves it emitted provided data about the Earth's ionosphere. Its orbit decayed until it burned up on the 4th of January 1958 while re-entering the atmosphere. It completed over 1,400 orbits. However, what some people don't realize is that Sputnik 1 was, as a science instrument, functionally useless. Much of the information learned from it was simply from putting something into orbit, but the satellite itself consisted of, essentially, 4 parts: a power supply of batteries, a radio transmitter, a sphere to contain these pieces, and 4 long whip-like antennas. What did these 4 parts do? They did this. That was the entire function of the Sputnik 1 spacecraft. It emitted a steady beeping sound that was transmitted over 2 different frequencies, switching between the 2 after a pause. This transmission was used to verify its location and that it was still operating, something that could easily be done by radio operators all over the world. The reason for Sputnik 1's extreme simplicity is easily explained when we examine the historical context. On July 29, 1955, US President Dwight D. Eisenhower announced through his press secretary that during the International Geophysical Year, an international project of science cooperation in 1957, the US would launch an artificial satellite. 4 days later, Leonid Sedov, a leading Soviet physicist, announced that they would do the same. By the end of the month, the Soviet satellite proposal was approved, and Sergei Korolev began to design modifications of the R-7 rocket for satellite launches. At the time, the first payload was being designated Object D, and in July of 1956, the scientific tasks to be carried out by the satellite were defined. They intended to study the density of the atmosphere, solar wind, magnetic fields, and cosmic rays. However, by the end of the year, it was becoming clear that the complexity and ambitious design of Object D would not be feasible in time for their intended launch date in 1957. Fearing the US would launch a satellite first, OKB-MEI, the Soviet Defense Ministry's primary design bureau, suggested a stripped-down and easy-to-build satellite instead, Sputnik 1. Object D would later fly as Sputnik 3 in 1958, but because they were rushed and desperate to be first, the world's first artificial satellite was just a steel ball that beeped. The United States Earth Satellite Program began in 1954 with a program called Project Orbiter, which intended to put a satellite into orbit a la Eisenhower's announcement using a military Redstone missile. This proposal was rejected in 1955 by Eisenhower's administration in favor of the Navy's Project Vanguard, which was still working on its first test vehicle when Sputnik 1 launched. Vanguard TV-3 then failed immediately after launch and further disheartened the nation regarding US spaceflight technology.
The first and most spectacular of these was Vanguard at the end of 1957. There were other Vanguard failures. All achieved takeoff, but trouble occurred either in the second or third stages.
As a result, Project Orbiter was revived, now called Project Explorer, intending to launch on a Juno 1, derived from the Jupiter series of medium-range ballistic missiles. The Soviet Union had, by this time, already launched a second satellite, Sputnik 2. Nevertheless, Explorer 1 was launched successfully on February 1, 1958. It was put into an elliptical orbit of 358 kilometers, or 222 miles, by 2,550 kilometers, or 1,590 miles. It orbited with its instrumentation located in the nose of the empty fourth stage rocket casing as one piece. Its science payload, designed and built under the direction of Dr. James Van Allen, was intended primarily to detect radiation in space, something that had been theorized but never confirmed. Explorer 1 was the first spacecraft to successfully detect the belts of ionizing radiation surrounding the Earth, leading to Van Allen's name being attached to them. While Sputnik had been a rushed and highly stripped-down attempt to be first, Explorer 1 had time and care taken to allow for more robust and scientifically rewarding vehicles, which I find to be interesting, to say the least. Sometimes being second place has its benefits. There is some confusion when it comes to animals in space. While Laika the dog, launched aboard Sputnik 2 before the United States had even launched Explorer 1, was certainly the first animal to orbit the Earth, the full story of the history of animals in space is a little more complicated. The first animals to ever cross the Kármán line were actually a pair of fruit flies, launched aboard V-2 number 47 by the United States Army at White Sands Missile Range in New Mexico in February of 1947. The rocket was launched to an altitude of 109 kilometers or 68 miles, intending to study the effects of radiation exposure at high altitudes. Though previous flights below the Kármán line had failed and were not recovered, these particular fruit flies were recovered safely. Following this, Albert II, a rhesus monkey also launched on a US V-2 rocket, became the first primate in space. Albert II reached an altitude of 134 kilometers, though he did not survive the flight due to a parachute failure on descent. Following this, monkeys of several species were launched by the US, with sensors attached to monitor their various vital signs. The death rate among these monkeys was very high. Around 2/3 died either on or shortly after landing. After the US sent a few more mice into space, and also killed them due to parachute failures, the Soviet Union began to launch dogs into space. The first were two dogs named Gypsy and Dezik, who were launched to an altitude of 110 kilometers in August of 1951. They were both recovered successfully, though Dezik would die on a second suborbital flight with a dog named Lisa, who also didn't survive. Two more dogs would first run away before their launch, and then be recovered, one of which made a successful suborbital flight, and one which made an unsuccessful one. And I personally want to read the story of the Soviet guard who kept falling asleep while watching the space dog kennel. Following this, in 1957, comes finally the launch of Sputnik 2, carrying the first animal into orbit. Also launched on the Sputnik rocket, this spacecraft was a little more robust, carrying a power source and antenna system similar to Sputnik 1, but also having a Geiger counter and spectrophotometers to study radiation and cosmic rays. Below all of this was the crew cabin for Laika, who was a stray mongrel dog found on the streets of Moscow, making her true pedigree and age somewhat unknown, though she was believed to be 2 or 3 years old. Her being a stray was an intentional choice, as there was an opinion that such an animal had already adapted to survive in difficult conditions, and the effects of longer duration spaceflight on living creatures was still very much unknown at the time. The name she was given translates to barker, as, despite her good performance and training, she was reportedly a very loud dog. Laika was held in place in her pressurized cabin by a harness, though it allowed enough room for her to stand or lay down. Not that this would matter much once she was in orbit. She was fitted with electrodes to monitor her vital signs, a bag to collect waste, and the cabin had a food dispenser to feed her in a gelatinized form. Her launch went exceptionally well, placing her and the satellite into a 225 kilometer or 140 mile by 1,671 kilometer or 1,038 mile orbit. Most people know about this part, but what is less talked about is what happened once she was up there. Official Soviet reports at the time stated that Laika survived a week in orbit, and while she was never planned to be returned to Earth in the first place, the truth of her fate is much darker. The Soviets had difficulty tracking the satellite on its first few orbits. However, telemetry data confirmed that for 3 orbits, Laika's vital signs were normal. On the 4th orbit, however, data showed that the temperature inside the cabin had risen to an alarming 43 degrees Celsius, and Laika was moving around, a lot. At this point, they lost track of the satellite, but when they picked it up the next day, the data showed no signs of breathing, blood pressure, or heart rate, but the cardio sensor was continuing to register a heartbeat. By the 3rd morning, Laika was confirmed to be dead, having succumbed to 2 days of overheating and carbon dioxide buildup. Her death sparked a fair amount of controversy surrounding cruelty to animals, as not only was Laika doomed anyway, knowledge that she likely died panicking and afraid made people extra critical of the situation. Some Soviet space officials expressed remorse about her fate, and a poem critical of the space program circulated Moscow in the months following the mission. Reportedly, the day before her flight, one Soviet scientist was already remorseful of what he knew was to happen to her. He took her home with him that night, allowing her to play in his backyard with his children. Contrary to her given name, Dr. Vladimir Yazdovsky wrote that, "Laika was quiet and charming. I wanted to do something nice for her. She had so little time left." Following Sputnik 2, both the Soviets and the US launched a number of animals on more suborbital flights. For the Soviets, it was more dogs, and for NASA, it was chimpanzees. By this time, NASA's first crewed space program, Project Mercury, was well underway. Through 1959 and 1960, a number of tests have been conducted on the Mercury spacecraft, utilizing different launch vehicles for different purposes, such as testing the in-flight abort system, the heat shield, the Atlas-Mercury interface, and other components. Finally, Mercury Redstone 1A verified the spacecraft for suborbital flight, and on Mercury Redstone 2, launched in January of 1961, NASA sent the first great ape into space, a chimpanzee named Ham.
3, 2, 1, 0, fire, liftoff. And Ham is on his way.
Ham traveled to an apogee of 253 kilometers or 157 miles, and after 16 minutes, he safely splashed down in the ocean. Knowing now that it would likely be safe to do so, the Mercury program began suborbital crewed flights with human beings, but before sending a person to orbit, they would send a second chimpanzee named Enos into orbit aboard Mercury Atlas V. So while the Soviets certainly do get the record for first animal into orbit, the USA was very quickly following in their footsteps, though the two simply had different methods. NASA wouldn't send a higher animal into space without a system in place to return them, though it still took a few non-human lives before those landing systems were perfected. The Soviets, more focused on maintaining their leadership, sent Laika to die knowing that she would die, but only a year later would repeat the feat with two dogs, who did in fact return safely. The Vostok program was the Soviet competitor to NASA's Project Mercury, and both were aiming for the same goal: put the first human being into space. The Vostok program moved fast, beginning cosmonaut selection as early as January of 1959. It was insisted upon that the candidates be qualified Air Force pilots, arguing that their experiences with high G-forces and ejection seats would be necessary. Sergei Korolev gave very specific qualifications for the candidates. They must be male, between 25 and 30 years old, be no taller than 1.75 meters or 5 feet 7 inches, and weigh no more than 72 kilograms or 158 pounds. By January of 1961, the Soviets had established the Vanguard 6, their first group of cosmonauts to be sent on crewed space missions. The first cosmonaut was Yuri Gagarin, 27 years old and an Air Force veteran with over 166 hours of flight time. Gagarin was a favorite among the original 20 candidates. When asked who they would prefer if someone other than themselves were chosen, all but 3 chose Yuri. Vostok 1 was launched on the same rocket that flew several uncrewed missions before it, the Vostok rocket, derived from the same R-7 family that launched the Sputnik program. It took a lot of adjusting, as almost half of the early Vostok launches were failures. Vostok 1, however, lifted off successfully from Baikonur Cosmodrome off a launch pad that would later be named Gagarin Start. The Vostok spacecraft was safely placed into a 181-kilometer or 98-mile by 327-kilometer or 177-mile orbit for a flight that lasted around 106 minutes. The entire mission was to be controlled from the ground, as at this point the effects of a weightless spaceflight on a human being was completely unknown. However, in an unusual move, a sealed envelope was placed aboard the capsule with a code that could be entered to unlock the manual controls in the event of an emergency: 125. Nikolai Kamanin, the head of the cosmonaut training program, as well as several others, also directly told Gagarin the unlock code before the flight, though, as far as I can tell, the manual controls never needed to be unlocked. While in orbit, Gagarin continuously reported back about how the spacecraft was operating and how he was feeling, both of which remained nominal. He mentioned being able to see the Earth below him through a small window located beneath his feet, and requested information about how the flight was going, much of which ground control was unaware of until nearly a half hour into the mission. After about an hour, Gagarin had nearly completed his orbit, and the automatic orientation system turned the Vostok spacecraft around for retrofire. The retro rockets burned for about 42 seconds over the west coast of Africa, about 8,000 kilometers or 4,300 miles from its intended landing zone. 10 seconds after the retrofire completed, the Vostok service module separated from the re-entry module. However, the equipment module remained attached to the re-entry module by a bundle of wires. As the capsule re-entered the atmosphere over Egypt, it began to gyrate uncontrollably for a moment before the wires broke off and the equipment module separated. Though the capsule continued to gyrate slightly, Gagarin reported that everything is okay. Reportedly, he hadn't wanted to worry anyone, and he believed the gyrations were actually something normal. He turned out to be correct, as they were simply a side effect of the capsule's spherical shape. After a fiery re-entry with intense G-forces, Vostok 1 reached an altitude of 7 kilometers or 4.3 miles. At this point, the capsule released its hatch, and Gagarin, in his seat, was ejected out, similar to an aircraft ejection seat. His parachute opened immediately, and he spent 10 minutes coming to the ground and landing near a farmer's property in the town of Engels, Russia. The farmer and his granddaughter observed the scene of a man in a bright orange suit and white helmet descending from the sky and landing. He approached them with his parachute still dragging behind him and, according to him, when they saw me in my spacesuit and the parachute dragging alongside as I walked, they started to back away in fear. I told them, "Don't be afraid, I am a Soviet citizen like you, who has descended from space, and I must find a telephone to call Moscow." What Yuri Gagarin and the Vostok program engineers achieved that day was remarkable and an undeniable first. Not only did the Soviets skip the step of suborbital crewed flights and sent a person straight into orbit, but unlike their first animal, they recovered him safe and sound. The Union was deservedly celebrating a great triumph. Gagarin's remark at liftoff, roughly translating to "let's go," became a household phrase. While officially, the United States congratulated the Soviet Union on its accomplishment, unofficially, they were afraid. A lot of fear-mongering went around regarding spaceflight's potential implications in the Cold War, and President Kennedy was quoted as saying it would be, quote, some time before the US could match the Soviet rocket technology. While there is no denying the achievement Gagarin and the team made on Vostok 1, there is one technical note that should be addressed. The FAI, or World Air Sports Federation, is the governing body responsible for aeronautic and space records, established in 1905. Following Vostok 1, the FAI recognized 3 space records claimed by Gagarin: duration of orbital flight, greatest altitude in Earth orbital flight, and greatest mass lifted into Earth orbital flight. In 1961, FAI rules required that, in order to be considered an orbital spaceflight, the pilot had to land with the spacecraft. And that's exactly what happened, the USSR told them. It wouldn't be until 1971 that they revealed Gagarin was ejected before landing, but nevertheless, the FAI reaffirmed the records, acknowledging that the crucial steps of an orbital spaceflight had been completed, even if the USSR had cheated just a little bit. Despite the fear and paranoia in the United States, NASA had begun its first crewed spaceflight program, Project Mercury, 3 years before Gagarin's historic flight. They would quickly catch up to the Soviets and soon begin to exceed them in some areas. They would launch their first astronaut on a suborbital spaceflight in May of 1961, just 3 weeks after Gagarin's flight. Alan Shepard rode the Mercury Redstone launch vehicle to an apogee of 187 kilometers or 101 miles. Less than 1 year later, in February of 1962, Mercury Atlas 6 would carry John Glenn on the first crewed orbital American spaceflight, completing 3 orbits before returning to Earth safely. At this point, the space race was truly underway, and efforts were only going to ramp up from here. One more thing I'd like to quickly mention before we continue is something that has very little to do with Vostok 1 directly, but something I find to be a sad and unfortunate set of circumstances. On March 27, 1968, Yuri Gagarin was doing a routine training flight in a MiG-15 fighter jet with another pilot. At some point, near a small village in the Oblast region, the plane crashed and both pilots died. How? What happened? Nobody knows. The final fate of the first man to ever reach outer space is wrapped in complete secrecy, even to this day, after the Soviet Union has long become a thing of the past. That I find to be very unsettling and very disrespectful to a man who should have been a national hero. All of mankind deserves to know what happened to this pioneer of history, but unfortunately, we will likely never know. Vostok 6 launched on June 16, 1963. While the previous Vostok flights had several technical delays, this one went off without a hitch and launched Valentina Tereshkova, the first woman in space, into orbit for nearly 3 full days. Much like other flights of the program, the official goals of the mission were continued evaluation of cosmonaut health, the various systems of the spacecraft, and on this particular flight, attempt to make contact with Vostok 5, also in orbit at the time. While brief radio contact was made, the 2 spacecraft remained too far apart to establish any kind of visual contact. Otherwise, Vostok 6 was considered a complete success when Tereshkova ejected and parachuted to the ground on June 19th. While the achievement of putting the first woman into space again cannot be denied, it is important to note the context of this mission. Why was Valentina Tereshkova the first woman in space? Because, like so many other firsts, the Soviets wanted to beat the Americans. Having learned about the Mercury 13, a group of NASA women who were training to be astronauts, Nikolai Kamanin wrote in his journal that, quote, "We cannot allow that the first woman in space will be American. This would be an insult to the patriotic feelings of Soviet women." He immediately moved for several women to be added to the next group of cosmonauts in the Vostok program, and Tereshkova was officially selected in February of 1962. On Vostok 6, both of Tereshkova's backup pilots were also women. the only women in the entire program. And who was Valentina Tereshkova herself? She was a textile worker. She was recruited because she had amateur skydiving experience, and like other candidates, she had no formal military or pilot training until she joined the Vostok program. They practically plucked her out of a lineup of women they had pulled in off the streets. It is entirely possible that Tereshkova's civilian and unaffiliated background is partially responsible for her poor performance. What often isn't discussed is how she behaved during the flight itself. Her own debriefing describes the flight going exceptionally well, and she says she took control of the spacecraft to test its orientation systems. However, after the flight, Sergei Korolev described being very disappointed with her performance and stated he did not allow her to take manual control as they had initially planned to. Communications with ground control regarding Tereshkova's health were described as evasive, and it would later be learned that she had suffered assorted body pains that she never reported. The problem with this is that part of the point of the entire mission was to assess cosmonaut health, as research had only just begun on space adaptation syndrome, a condition experienced by almost half of all astronauts even today. Caused by the human body attempting to adapt to a weightless environment, Tereshkova was clearly feeling the effects of this condition, as had the pilot of Vostok 5. She had vomited while attempting to eat, and again, wouldn't mention this to ground control until her debriefing. One source also stated that after landing, she had given her leftover food to local villagers. While a kind gesture, that food was part of a science experiment, and she had given away the results of said experiment, making it a failure. Unlike Yuri Gagarin, Valentina Tereshkova remains alive to this day. While this holds no relevance to her achievement in space, her actions since it have been not great. Tereshkova is currently a member of the Russian State Duma and is an extremely vocal supporter of Vladimir Putin. Sadly, the Vostok program is a long way behind her, and it shows. There would not be another female Russian cosmonaut until 1982, when Svetlana Savitskaya flew aboard Soyuz T-7. Korolev had launched Vostok 6 as yet another novelty, a first that would be easy to achieve, and it was clear that pioneering women's rights in spaceflight was far from a priority for the Soviet space program. Granted, the USA didn't do much better. Their first woman in space was Sally Ride in 1983. This is an area that all of spaceflight could really do better in. Much like Project Mercury was succeeded by Project Gemini, yes, it's pronounced Gemini, blame NASA, not me.
Gemini began counting down. Gemini 1. Gemini number 1 lifted smoothly off the pad. The second flight test of the Gemini program.
In order to start to perfect the techniques of orbital spaceflight, the Vostok program was succeeded by the Voskhod program. It was short-lived with only 5 total missions, 2 of which had crew. It would later be cancelled, primarily because of how quickly Project Gemini would catch up and overtake it, and be superseded by the Soyuz program. Initially developed as part of the Soviets' manned lunar goals, this program continues today as Russia's primary crewed spaceflight program. Voshod's primary goal was to beat Project Gemini to the first multi-man cruise in orbit, and once it had achieved that with Voshod 1, it lacked direction. Voshod 2 was the only other crewed flight it made, and this one did achieve a very interesting first, the first spacewalk. The Vostok-derived spacecraft was equipped with an inflatable airlock, which would allow one of the 2 cosmonauts aboard to exit the spacecraft within a spacesuit. While Voshod 2 did achieve this goal, a closer look at the mission's details and its fair share of problems are worth looking into. Launched on an R-7-derived rocket on March 18th of 1965, Voshod 2 completed 17 orbits over 1 day and 2 hours. Its crew was Pavel Belyayev and Alexei Leonov, the latter of whom would conduct a 12-minute spacewalk during the mission. The crew landed in the spacecraft on March 19th, and the mission was reported as a complete success. The Soviet space program proclaimed that they had proven a person could effectively perform work in outer space, but the truth was a little more complicated, and became so the very second Leonov stepped out of the airlock. Leonov exited the spacecraft with a tether to keep him connected to it, and when he pushed away from the spacecraft, he entered an uncontrolled spin. Unable to do anything about it, he simply had to wait until the tether reached its limit of 7 feet and jerked him to a stop. Only a few seconds later, Leonov made a realization. His suit was changing shape. In the vacuum of space, it had begun to unexpectedly balloon outwards, restricting his movements far more than had been intended. His hands and feet kept slipping out of the boots and gloves, and he realized, not knowing when the inflating would stop, he soon might not be able to re-enter the spacecraft. He had a camera mounted on the chest of his suit, which he was supposed to use to take pictures of the Voskhod spacecraft, but he wasn't able to reach the shutter on it. He did recover the camera mounted on the spacecraft with significant exertion, which is why we have this footage of his spacewalk. When he pulled himself back with the tether and re-entered the airlock, his fears were realized when he couldn't turn around to close the outer door. He decided to slowly vent the pressure out of his suit to about half of what it should have been, flirting with decompression sickness until he was able to turn around and close the door. He then re-entered the spacecraft head first, which he wasn't supposed to do, causing him to struggle more than he should have. This extra exertion brought his body temperature dangerously close to heat stroke territory, but he managed to get into the spacecraft and sit back down on the couches installed in it. In a later interview, Leonov stated that, in case he was unable to re-enter the spacecraft, his suit had been fitted with a pill that he could take that would end his suffering quickly. Voskhod 2's problems didn't end with the spacewalk. After Leonov was safely back inside, Belyayev jettisoned the inflatable airlock and quickly realized that the spacecraft hatch wasn't sealed properly. To compensate for this, the climate control system was increasing the oxygen pressure in the capsule, which also increased the probability of any tiny spark igniting a fire in the super-oxygenated environment. This very issue had already killed a cosmonaut in training, and would later go on to kill 3 NASA astronauts in Apollo 1. After carefully getting the hatch sealed, another problem occurred when the automated re-entry system failed, and the cosmonauts were forced to perform the burn manually. This gave them little control over their landing zone, so they aimed for the taiga of Russia, a vast stretch of forests in the northern regions of the country. They struggled to get back into their seats, and this would change the vehicle's center of mass. Their trajectory was again changed by this uneven center of mass, pushing it almost 400 kilometers away from where they intended. As they re-entered the atmosphere, the service module failed to separate, similar to Gagarin's Vostok flight. However, its connecting straps eventually burned up in the heat of re-entry, and it broke away. As Voskhod 2 was slowed by the atmosphere and descended to the Earth, the cosmonauts glimpsed Moscow through the window. Leonov pointed to the red square and quipped, "We could land there if you want." The capsule ended up landing in the forests of the Perm region of Russia, and due to the wide range of error in its tracking system, the exact location wasn't known to the recovery teams. The crew waited in the cold snow overnight, building a fire due to a failure of the spacecraft's heating system, and Leonov spending significant time wringing sweat from his pants that had built up inside his suit. They watched for wolves and waited out the night until they were recovered safely early in the next morning. Leonov stated he lost 6 kilograms, or 13 pounds, of weight. While the many difficulties of Voskhod 2 would lead to the cancellation of the program in favor of the development of Soyuz, NASA's Project Gemini was just getting started. It was at this point that the United States began to catch up with their own firsts in space. Gemini 4 performed the first American spacewalk only 3 months after Voskhod 2, and as they had learned from its mistakes, it went much more smoothly. Following this, Gemini 6A performed the first rendezvous in orbit, coming within 1 foot of its sister spacecraft Gemini 7. Gemini 8, despite a later critical failure that forced an immediate mission abort, performed the first docking of 2 spacecraft in orbit with the automated Agena target vehicle, before returning its crew safely. Last but not least, Gemini 12 performed what can be argued as the first useful spacewalk, when Buzz Aldrin performed 3 EVAs over 4 hours in combined length, and performed a number of tasks that effectively proved that an astronaut could do critical work in a spacesuit. NASA and the United States were very much growing in the rearview mirror of the Soviet Union. The next step of the Soviet lunar program was development of their Soyuz spacecraft. This craft consists of 3 primary components: an orbital module, in which cosmonauts work while in orbit, a service module that contains the majority of the craft's propulsion, long-range communications, and power systems, and a descent module that is used both for launch and re-entry and landing. Soyuz I was to be the first crewed test flight of the first-generation Soyuz spacecraft. The flight was plagued with issues, and may have been doomed from the moment Korolev ordered for it to be launched despite the failures of the previous uncrewed tests. Its sole crew member was Vladimir Komarov, who had also flown on Voskhod 1. In the months before the flight, Komarov had voiced a number of concerns about design problems with the Soyuz spacecraft, such as the insufficient size of the hatch between the orbital and descent modules. He and the other cosmonauts were greatly concerned both with the lack of response from the engineers about their concerns and the constant shuffling of their training groups and assignments. Komarov was selected to fly Soyuz I in 1967, with his backup pilot being Yuri Gagarin. According to interviews with a former KGB agent named Veniamin Rasayev, Gagarin attempted to bump Komarov off of the mission and fly him instead. Gagarin knew Soviet leadership would not risk a national hero such as himself on the flight and would cancel it in order to fix its many issues. At the same time, Komarov refused to pass on the mission himself, even though he doubted its success, stating he could not risk Gagarin's life either. However, it is worth noting that Rasayev's account is somewhat disputed. Soyuz I launched successfully on April 23, 1967, carrying the first cosmonaut to ever go to space twice. Problems began immediately once the spacecraft was in orbit, when one solar panel failed to unfold, which both prevented the vehicle from coming to full power, as well as obscuring some of the navigations equipment. Komarov reported to ground control the following: "Conditions are poor. The cabin parameters are normal, but the left solar panel didn't deploy. The electrical bus is only at 13 to 14 amps. The high-frequency communications are not working. I cannot orient the spacecraft to the sun. I tried orienting the spacecraft manually using the DO-1 orientation engines, but the pressure remaining on the DO-1 has gone down to 180. The original plan for Soyuz I was complex. A second spacecraft, Soyuz II, was to be launched shortly afterwards, and the crew was to rendezvous and EVA over to Komarov's spacecraft. However, after Komarov attempted unsuccessfully to orient himself for 5 hours, the mission was called off, and Komarov was ordered to come home. After 19 orbits and a complicated re-entry burn, the spacecraft re-entered the atmosphere and slowed to subsonic speeds. To slow it further, the drogue parachute was deployed, followed by the main parachute. However, the main parachute wouldn't correctly unfold, nor would the drogue detach itself. Komarov acted the deployed reserve chute, but it became entangled with the drogue chute. The descent module fell to Earth in Orenburg Oblast, Russia, almost completely unimpeded, and impacted the ground at around 140 kilometers an hour, or 89 miles per hour. According to listening posts in Turkey, his last words were cries of rage cursing the people who had put him on the spacecraft. By the time a rescue helicopter reached the crash site, the entire module was in flames, with black smoke filling the air and streams of molten metal dripping from the exterior. The rescuers fired a signal flare, and more rescuers arrived with fire extinguishing equipment, but they couldn't put it out. The entire thing crumbled to ruins, and when the fire finally ended, they dug through it and retrieved what was left of Vladimir Komarov, who would later be named a hero of the Soviet Union. Supposedly, Komarov had demanded a public funeral with an open casket, wanting people to see what had happened to him. There was a famous photograph of several Soviet officers standing next to his casket. I won't show it all to you, but if you truly did want it to be seen, I'm sure you know how to find it for yourself. Vladimir Komarov made the ultimate sacrifice by being the first in-flight fatality in the history of spaceflight. He showed people that space is dangerous, going there is hard, and these things should never be rushed in lieu of safety. At the same time, Komarov's death somewhat represents the beginning of the end of Soviet supremacy in space. His flight was a rushed attempt to get the Soviet lunar program started, and would be the first of many setbacks in said program. While only a month earlier, NASA had suffered their own serious tragedy in the form of Apollo 1, from this point forward, the Soviets would struggle to maintain any kind of leadership in spaceflight at all. Before anybody could even try to put boots on the moon, a few important questions needed to be answered. Remember that in these pioneering days, nothing like this had ever been attempted, and it wasn't known if we could make an object orbit the moon, let alone land on it. It wasn't known what the composition of the moon's surface was, and whether or not a spacecraft would simply sink into its soil. To answer all of these questions, the Soviet space program began the Luna program, to land a robotic spacecraft on the surface of the moon. Begun as early as 1959, the Luna program was very secretive and did not assign numbers to launches that failed to reach orbit, making the total number somewhat unknown. 24 spacecraft were formally given the Luna designation, while those that failed in low Earth orbit were usually given Cosmos designations instead. Their purposes ranged from flyby of the moon, to orbit, to hard impacts, and finally, soft landings. Each of these types of missions would have a competing US program with the Ranger impactors, Pioneer flyby spacecraft and orbiters, and Surveyor for landers. Both programs had mixed success, with high failures on both sides, but throughout it all, Luna remained ahead of the game. Luna 1, launched in January of 1959, missed an intended lunar impact and became the first object to escape the Earth-Moon system. Luna 2 became the first object to reach the Moon in September of the same year, when it was successfully impacted on the surface. This was its only successful impact out of 6 tries, while 2 years later, the US Ranger program would achieve 4 impacts out of 9 attempts. Luna 3 in October of 1959 returned the first images of the far side of the Moon after its first successful flyby, one of 3 attempts to do so, which is oddly the same result as the competing Pioneer program, which performed a flyby in March of the same year. Ramping up the difficulty, the Luna program went straight from these flybys to landing attempts, sending 13 probes toward the Moon and landing 2. In February of 1966, Luna 9 performed a successful descent to the Moon using retro rockets and airbags to cushion its landing. It bounced several times before coming to rest on the lunar surface. It would later return this image, the first image ever taken from the surface of another world. The Soviets have successfully proven that soft landings on the Moon were possible and gave extra confidence to both nations' crewed lunar programs. While they were struggling to hold on to any firsts, and the Soviets were about to lose the space race, their attempts to remain in the lead in space would continue after the lunar landings. We're about to move away from the Moon, but don't worry, we'll come back. The Almaz program was begun in the early 1960s, a highly secretive military space station program run by the Soviets. While it was becoming increasingly difficult to hide operations in space, the program was disguised by blending it with a civilian space program called Salyut. The first station, Salyut I, was launched in April of 1971 aboard a Proton K, a rocket that was initially conceptualized as a heavy-lift ICBM. Having lost the race to the Moon, priorities were shifted to orbital infrastructure, as well as an attempt to one-up the US Skylab program, which was still in development. Salyut 1 was successfully placed in a 200-km or 124-mile orbit without crew, who would later come aboard a Soyuz spacecraft. Salyut 1 was a single piece with 3 distinct compartments: a transfer compartment for docking, a main compartment about 13 feet in diameter, and an auxiliary compartment that contained all of the control, power, and communication systems. Despite extensive amount of scientific equipment aboard the station, little work was actually done, as Salyut 1 saw only 2 visiting crews, and both occasions did not end well. Soyuz 10 launched at the end of April 1971, with the station itself being launched only 5 days earlier, carrying 3 cosmonauts. After they successfully performed a rendezvous with Salyut 1, the automatic control system failed during approach, forcing the crew to take manual control. They managed to soft dock, which is to say they managed to connect to the station without a full docking link, but the computer sensed an abnormality that caused it to fire its attitude thrusters. Soyuz 10 was being pushed to one side, making it impossible to finish the docking procedure and expending large amounts of propellant in the meantime. Deciding to abort, the crew attempted to back away, but the docking probe wouldn't detach from the station's docking cone. The crew considered leaving the orbital module behind, but this would effectively kill Salyut 1, as no future crews would be able to board and the station would have to be abandoned. The settled solution was simple but effective. The crew threw a circuit breaker in the docking mechanism, which caused the probe to automatically retract when power was returned to it. Soyuz 10 was able to return to Earth safely, and plans were drafted to fix the spacecraft for another attempt. On June 6, 1971, Soyuz 11 launched 3 more cosmonauts, and they again performed a rendezvous with Salyut 1. On flight day 2, Soyuz 11 came within 7 kilometers of the station, at which point the automatic control system took over. After a period of 24 minutes, the spacecraft slowed its approach to around 0.2 meters per second before manual control was given at a distance of 100 meters. A full 3 hours later, docking was successfully achieved and the hatches were opened. The crew passed into Salyut 1 to discover that the atmosphere inside was smoky and smelled burnt. They quickly replaced part of the ventilation system and spent the next day back in the Soyuz spacecraft until the air cleared. Their stay was then productive, despite a brief fire on day 11, not much information available about that, and discovering that using the exercise treadmill caused the entire station to vibrate. The crew intended to observe an N-1 rocket launch from orbit, but the launch was postponed until after they left. Soyuz 11 undocked on June 29th, and the crew flew alongside the station for a while until the deorbit burn occurred. Shortly before atmospheric re-entry, the descent module separated from the other 2 modules, and the capsule landed after an apparently totally normal procedure about 25 minutes after the re-entry burn. The recovery team approached the capsule and opened it, finding all 3 crew members, Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev, dead in their seats. The cause of the cosmonauts' deaths was not immediately known, nor revealed to the public. This sparked a brief period of panic when speculation arose that extended time in space was what had killed them, which would make long-term spaceflight impossible for the time being, and would also seriously delay or cancel most upcoming space programs. However, the Soviets had quickly determined what had happened. The crew had asphyxiated. The fault was traced back to a breathing ventilation valve that had been jolted open when the Soyuz module separated. A failure of the explosive bolts had jostled it and opened it at an altitude of 169 kilometers or 104 miles. The cosmonauts would then only have about 3 seconds to react, and in fact, Viktor Patsayev appeared to have tried to do something as his body was found near the faulty valve, and he may have been attempting to close it or block it when he died. To this day, the cosmonauts of Soyuz 11 are the only people to have ever died above the Kármán line in space. The failure of Soyuz 11 effectively killed Salyut 1, as redesigning the spacecraft would take much longer than the station would remain in orbit. After 175 days, the world's first space station was destroyed when it burned up over the Pacific Ocean. Several other Salyut stations would launch, with similarly mixed success and much of it shrouded in military secrecy. Meanwhile, 2 years later, the United States would launch Skylab, and it would be occupied for 24 weeks between May 1973 and February of 1974. While Skylab had its own issues, including a primary solar panel that failed to deploy, it is at least noteworthy that while the Soviet Union holds the record for the first space station, the United States holds the record for the first crew of a space station to survive. After man had landed on the moon, a clear next step was to begin landing on other planets. Mars was a popular target due to its similarities to Earth as well as its relatively short distance. The Soviet Mars program, while beginning in 1960, began to make actual strides in 1971 with Mars 2. It became the first man-made object on Mars on May 19th when it crash-landed after its parachutes failed to deploy. The next craft, Mars 3, would perform a successful landing and officially become the first spacecraft to land on Mars. Or would it? Mars 3 landed on Mars through a combination of aerobraking, parachutes, and retro rockets, touching down at 45 degrees south and 202 degrees east on December 2, 1971. The lander began transmitting back to the Mars 3 orbiter 90 seconds after the landing, and 20 seconds after that, the transmission stopped. Mars 3 would never speak again, managing to only transmit 70 lines of a partial image of the Martian surface. The cause of the lander's failure is obviously not known. The incredibly small amount of data gathered and time lasted after touchdown call into question the validity of it as a successful achievement. The US Viking 1 spacecraft landed 5 years later and went on to operate for another 6 years, and while it isn't simple as saying Mars 3 doesn't count, I feel like it barely counts. On the other hand, there is a similar interplanetary achievement made by the USSR that cannot be denied and continues to stand alone to this day. The Venera program, which explored the planet Venus, resulted in not only the first spacecraft on another planet, but the only spacecraft to ever land on Earth's hellish twin. Over the course of the Venera program, which included flybys, orbits, atmospheric data collection, and eventually landers, 10 probes successfully touched down on the surface of Venus. They experienced mixed success, with some being crushed by the sheer pressure of the Venusian atmosphere, though several landed and worked for several minutes. Venera 9 sent back the first images from the surface of another planet, and Venera 13 returned the first color images. In addition, Venera 13 was fitted with a microphone and returned back audio of Venusian wind, the lander's impact on the surface, and analyzed the composition of its soil with a spectrometer. Designed to last for only 23 minutes, Venera 13 continued transmitting for an astonishing 2 hours before it, like all others sent there, was crushed by the pressure of the atmosphere. At the end of the day, even if Mars 3 can be written off as a technical failure, and that is a big if, giving the first Mars landing to the Viking program, the Venera program remains, to this day, unmatched. While Soviet interplanetary firsts were a struggle, this much cannot be taken away from them. The Venera program was a truly impressive, undeniable achievement. In 1977, NASA began testing of its first reusable launch system, the Space Transportation System, or STS, better known as the Space Shuttle. To counter this, the Soviet Union developed the Buran program, which included the Buran-class orbiter, as well as the Energia launch system. Energia was capable of lifting payloads outside of the orbiter, making it a more robust design, and dished the solid rocket boosters in exchange for twice as many liquid-fueled boosters. In addition, rather than mounting the launch system's main engines on the orbiter itself, the RD-170 engine that powered Energia was mounted on the core stage of the rocket itself. The orbiter, once the launch system separated, then moved around using a smaller propulsion system similar to the orbital maneuvering system engines on the space shuttle. This saved a lot of weight and allowed the orbiter to increase its payload capacity, bringing it to 30 tons as opposed to the shuttle's 24 tons. Without the orbiter, Energia was capable of launching payloads as heavy as 100 tons, qualifying it as a super heavy lift vehicle that would be able to accomplish what the N-1 rocket wasn't able to. In many ways, Buran was not only as good as the NASA shuttle, but arguably better. Its larger payload capacity was complemented by an automated approach and landing system, meaning that it could touch down on a runway all the way from orbit without a human being ever touching the controls. So, what went wrong exactly? Why does everybody know about the NASA space shuttle, but Buran is only known by the aerospace community? Well, the answer is simple. Buran flew exactly once. Energia was tested once before it performed a Buran flight, with its payload being the Poyekhali spacecraft. Poyekhali was a prototype orbital weapons platform designed to destroy spy satellites, essentially working as a counterpart to Buran's ability to retrieve satellites. I could spend all day talking about why Poyekhali was a horrible idea in the way that all anti-satellite equipment is a bad idea, but I'll just say this to you. Do you want Kessler syndrome? Because that's how you get Kessler syndrome. Thankfully, Poyekhali was never deployed. Though Energia functioned perfectly and placed the craft into low Earth orbit, Poyekhali turned around in a full circle instead of the 180-degree turn it was supposed to do, and deorbited itself, caused by a faulty inertial guidance system. The Buran program was developed to directly compete with the NASA shuttle, as it could do something no other spacecraft before it could: return a satellite from orbit. The Soviets were concerned that any experimental military payloads could later be found, retrieved, and studied by the United States using the space shuttle. While reluctant to do so, Buran's outward design was very similar to the NASA shuttle, obviously, as wind tunnel testing had already shown its rough shape to be the ideal spaceplane design. Construction of the orbiters began in 1980, and the first full-scale Buran was rolled out in 1984. This test vehicle also had 4 jet engines mounted at the rear, allowing for it to do its atmospheric test flights without needing to first be lofted by a carrier aircraft like the NASA shuttle was. By 1988, the first orbital vehicle was ready, Buran OK-101, and it was mated to the Energia launch system in November of that year. On November 15th at 3 a.m. UTC, Buran lifted off from Baikonur Cosmodrome and was lofted into a temporary orbit. The Energia system then separated, and the orbiter pushed itself into a higher orbit. After completing 2 trips around the Earth, the engines fired again to deorbit the vehicle. Buran touched down under its own control at 6:24 UTC and came to a stop 206 minutes after the launch. Despite the presence of high lateral winds, the automated landing system brought Buran only 3 meters or 10 feet from its intended target. It lost only 8 of its 38,000 thermal protection tiles over the course of the flight. After such a successful first mission, one likely begins to wonder why the program was so suddenly cancelled. The first thing one must remember is the period of time this took place in. Buran's debut flight occurred only a couple of years before the Soviet Union itself would completely collapse, leaving the Soviet space program in complete disarray. Citing a lack of funds, the project was suspended on June 30th, 1993, with 2 orbiters never being built, and 20 billion rubles, or about $329 million US, with only 1 flight to show for it. A program that had been designed to bring back Soviet space superiority and boost national pride was completely gone. Plans had already been drafted to dock Buran to the Mir space station, and with the program cancelled, The station would instead be visited by the NASA shuttle. Buran was perhaps the most ambitious program in the Soviet space program's history, and while it shot for the stars, it would land sadly in a hangar in Kazakhstan that would eventually collapse and destroy it. This was the true end of Soviet space supremacy, but before we wrap things up, we need to rewind a little. We need to revisit the end of the space race. We need to go back to the moon. At the beginning of the final lap of the space race, the Soviets were beginning to lose the lead. Project Gemini quickly caught up to and exceeded those of the Voskhod program, and the Soyuz program suffered serious setbacks after the failure of Soyuz I. Sergei Korolev had been working on the development of a Soviet lunar program for some time. His initial plan had been complex, including a lunar vehicle that would be assembled in Earth orbit. After the United States announced the Apollo program, focus was shifted to the N-1, the Soviets' response to the Saturn V, a massive super heavy lift launch vehicle that could accomplish a lunar mission in a single launch. After Korolev had put all the pieces on the table and told everyone what they needed to do, a serious wrench was thrown into the gears of the Soviet lunar program. Sergei Korolev died. His health had been in decline since 1962, with numerous ailments from arrhythmia to inflammation of the gallbladder, as well as fatigue from the massive amount of work he was putting into the program. He died in January of 1966, in hospital, and the Soviet space program would never be the same. N-1 was a monster of a rocket. Though physically slightly smaller than the Saturn V, it was designed to have more thrust in each of its 3 stages than the corresponding Saturn stages. Its first stage utilized an unheard of 30 engines to power it, and due to their design, they could not be each static fired before launch. This inability to test these many engines would result in endless problems for the N-1 program. While no failure was ever directly caused by the engines, they were mostly caused by transient voltages and fuel leaks, things that static fires would have told the engineers about if they could perform any, but they couldn't. Though seriously hindered, the first N-1 rocket was ready and on the pad February 21st, 1969. By this point, the Apollo program had only just finished a crewed lunar orbital flight with Apollo 8, and in a desperate bid to keep up, N-1 had been rushed to the pad. A few seconds after it launched, a transient voltage shut down engine number 12, and in order to maintain symmetrical thrust, engine number 24 was also shut down. A few seconds later, pogo oscillations, which would also be a serious problem with the Saturn V, caused a fuel leak in engine number 2, and when a second leak started after that, a fire started. The fire burned through wiring that caused the entire first stage to shut down 68 seconds into the launch. It crashed 52 kilometers from the launch pad. By the time the second N-1 was ready, the race was already lost. A few months earlier, Apollo 10 had effectively performed a dress rehearsal for landing on the moon, while N-1 number 2 was intended for uncrewed lunar orbit and photography of potential landing sites. The flight lasted only a few seconds, as a fire caused every single engine to shut down save for one just as it cleared the launch tower, causing it to tilt and fall back directly onto the pad filled with fuel. The crash created, at the time, the largest non-nuclear explosion in human history. While the Soviets were still cleaning up the remains of their launch pad in July of 1969, Apollo 11 lifted off and brought Neil Armstrong and Buzz Aldrin to the surface of the moon. The flag was planted, and the race was over. N-1 would see 2 more flights, but both would fail, and the program was cancelled in 1974. Rushed, underfunded, and lost without Korolev's leadership, it represented the Soviets' last-ditch attempt to maintain the lead that they had held up until that point. By the time the space program had slowed down to develop innovative and promising systems like Energia and Buran, the country that program represented was on the brink of collapse. While it can be argued it was lost a little earlier, it can be definitively said that Apollo 11 put an end to Soviet space supremacy. The Soviet space program is not something that can be quickly dismissed. It was a truly impressive thing, especially in its early days. The dedication and hard work of the engineers to make achievements under heavy political pressure is commendable to say the very least. The bravery of the cosmonauts who loaded themselves into spacecraft that they knew weren't entirely safe, shoot themselves into space, and perform daring stunts the likes of which the world had never seen, makes them not just national heroes, but heroes of all of humanity in general. The United States had their own problems with their space program, beginning as early as the near drowning of Gus Grissom on Liberty Bell 7. Mismanagement and poor design killed 3 astronauts before Apollo ever got a man off the ground. Apollo 13 showed some of the rushed development of the American lunar program and nearly resulted in another 3 astronaut deaths. Following the space race, the shuttle program would go on to kill an unprecedented 14 astronauts, again through mismanagement and poor design. Neither space program was perfect, nor was either unimpressive. Both forced into action through politics, they ran a tight race up until the finish line, and the efforts of both would go on to change the course of human history forever. This video was not to say that the Soviets never held any superiority in space. They certainly did. It is merely to put that superiority into the correct context, to point out that the space race was far closer than it seemed, and to mention those things that often go unmentioned. I started out simply wanting to put some tankies in their place, but the truth is far more complicated than that. Space is hard, and the Soviets showed the world just how hard space can be. No matter what we do from here, we are following in their footsteps. Whatever you think about politics, the space program of the USSR was nothing if not a trailblazer. True space cowboys, or space comrades, or something.